This video covers how we compute the regression line for a set of data. Basically, we're already most of the way there. We just looked at how to compute the covariance for a set of data, which is the covariance is the variance co, or with. We're looking at how one variable, one numerical variable, is related to another numerical variable, and how those two vary together. Now, much earlier this semester, we looked at computing the variance for a set of data. We generally didn't really care about the variance in and of itself, save as a stopping point to get to things like a standard deviation and a test statistic that we really cared about. Same thing applies here. We generally don't care about the covariance per se. We use it as a stepping stone to get things that we do care about, namely the regression line and the correlation. And so let's continue our example. Same example we've been working, those are the data, and there's a graph of the data. We would like to find two things. We would like to find the regression line running through the middle of those data. We'd also like to find the correlation, which tells us how strong the relationship is between sleep and grade. Think back to high school. Y equals mx plus b. Slope of the line was x, the intercept, sometimes called the y-intercept, was b. What we want to find is the slope and intercept for our data. And we know how to find slope. Slope is rise over run. Same idea applies with one minor difference. You see, back in high school, they were being nice to us. I really don't approve of that. Seriously. The examples we had in high school analytic geometry class, the data points were all on a line. In the real world, the data points tend to scatter around the line. And so we need to take the same idea of rise over run, but we need to operationalize it in a somewhat different manner. How do we go about doing so? Glad you asked that question. Rise over run. A rise is how much y changes as we change the x variable. Have we seen anything in this or a previous life that measures how much y changes as we change the x variable? That sounds like a covariance to me. Rise over run. What's run? That's how much the x variable is changing. Have we seen anything in this or a previous life that measures variability in an x variable? That sounds like a variance to me. So basically, we're taking rise over run, covariance measures the rise, how much the y changes as we change the x. The variance of x measures the run, how much the x is changing. And so here is our, quote, formula, but it's really just our old friend from high school, rise over run. Do we know the covariance for our data? Yeah, that we just computed that in the previous example. Do we know the variance of the x's? Yeah, we computed that as well. And so our slope, rise over run, covariance or variance, is 7. What does that number mean? As x increases by 1, y increases by 7, right? On average. For every additional hour of sleep a student gets, grade goes up by 7 points on average. You're not guaranteed 7 more points, but as a general rule, 1 more hour of sleep tends to produce grades that are 7 points higher on average. So that gives us a slope. How do we get an intercept? Again, think back to what we did in high school. Once you know a slope, then all you need to do is plug in a point that's on a line, and you can get the intercept. And again, back in high school, all the points were on the line. In the real world, none of the data points has to be on the line. But there is one point that we know has to be on the line. And that point is the averages. Think about it. The line's running right through the middle of the data, and so it should hit that average point. And so we're finding the intercept. We know that y equals mx plus b. We just found that the slope was 7. Average x value, person got 4 hours sleep. Average y value was 70. Plug those in. Average x, average x, average y. We find that our intercept is 42. What does that number mean when x is 0, y is 42? People who get no sleep score a 42 on average. Again, some will do better than that, some will do worse, but in general, no sleep means a 42 on average. And so we found the slope and intercept of our regression line. Slope is rise over run, covariance divided by variance of the x's. Once we know that, we plug into the regression line, and the point we plug in is the average x and y value to get the intercept. And here, for our example, is the regression line. In the next video, we'll look at how to compute the correlation.